Okay, so this is our second part of this lesson, I guess, and that's the sine graph. Cosine. So we drew a sine graph, now you're going to draw a cosine graph. Starting the same point, guys. Write down a table, angles from 0, 30, 60, going up in 30s, all the way to 360. Use your calculator, find what the cosine value are. Okay, round up to, let's say, 2 decimal places. Use a graph paper if I send you one, or just in your books, like I've done here, plot the x-axis as the theta, all the way from 0 to 360, but in 30 differences, not like I did here, okay? And then cosine theta. Pause me now, fill in this table, draw the graph, I'm waiting for you here, I'm not going to go away. Please, please do it, it really helps you understand it better. And now we can look at your results, okay? So hopefully you find something like that, okay? You found again a wave, which we looked at a couple lessons ago, okay? Which again swings between 1 and -1. Maximum is 1, the minimum is -1. Crosses the graph at 90 and 70. And it reached the peak at 0 and 360. Okay? Now let's try and understand it, just like I did before with the circle. So I'll just pause. Okay. So I drew our little circle with a triangle in the middle. The radius is your radius, is hypotenuse. Okay? The y-coordinate and the x-coordinate of the angle theta. Okay? Now cosine theta is the adjacent over the hypotenuse. So now it's not the y-coordinate, it's the x-coordinate over r. So trying to find out what cosine theta, you need to always know what's the x-coordinate. Because the x-coordinate, as I move that point around the circle, the r doesn't change, the x changes. Also the y changes, but I'm not interested in the y because I'm doing the cosine. Okay? So just like I did in the sine graph, I'm going to look at specific angles. I'm going to look at 0, 90, 180, 270, and 360. Okay? Every 90 degrees. Now, what is cosine 0? Okay? This is the point 0. Okay? Here, this is theta equals 0. What is x equal? If I was to draw a triangle here, move that little dot over to here, what happens to the x-coordinate? As I move it down, the x-coordinate gets bigger, 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 bigger. Over here, the x-coordinate is exactly the same as r. X equal r, in this case. So what is cosine 0? It's r over r, which is equal 1. So I'm getting 1 here, and you can see it. The cosine graph starts at 1. That's the top. Okay? I'm making theta bigger. There you can see it. As I move the dot over here, making theta bigger, what happens to the x-coordinate? It becomes smaller and smaller and smaller. As this point moves here, the x-coordinate gets smaller and smaller and smaller. That's why the x-coordinate, or the cosine theta, gets smaller and smaller and smaller, until I get to here. Theta in this case is 90, right? Okay? What happens to the x-coordinate here? Well, there is no x-coordinate. This is a y-intercept. That means, by definition, x is 0. So cosine 90 is also 0. Okay? So it shrinks from 1 all the way to 0. Now, moving my dot, carrying on moving my dot, what happens to my x-coordinate? Maybe I'll draw one. Okay, I'm going to disappear here for a minute. Okay. This is my x, and this is my r. What happens to my x now? What happens to my x? Okay, my x becomes negative, isn't it? It's negative, I'm on the left side. So I'm going to have negative x. Over here, if I move all the way to here, at theta equal 180, okay, theta equals to 180, x, okay, is negative, and not just negative, it's exactly equal to minus r. We're over here now. We minus r. So cosine 180, I don't have space, cosine 180 equal minus r, that's the x-coordinate, divided by r, it's minus 1. It's minus 1. So cosine 180 is minus 1. This swings all the way to minus 1. Okay? I'm going to move that one, and I'm going to look now at 270. What happened with theta is 270 over here. Okay? So again, I got to ask myself, what is the x? Always, when it comes to cosine, I always got to ask myself, what happens to the x coordinate? X coordinate, okay, it's a y-intercept, so the x is 0. And if the x is 0, the cosine is also 0. So cosine 270, as you can see, is 0. Crosses again the x axis. Moving back to 360, okay, so now I'm at 360. Again, I got to where I started. So theta equals 360 is the same as theta equals 0. It's a periodic coordinate, okay? It goes back, and in both cases, the x, as I found before here, the x is simply equal to r, so cosine 360 is also 1, and you can see it goes back to 1. So it swings from 1 to 0 to minus 1 to 0 to plus 1. Create the whole period. Really, really important lesson, guys. I'm going to just finish it with comparing both graphs, so I'll pause you here. Okay, so just to finish up this lesson, I wanted to plot both graphs next to each other, and then we're going to add one bit to it. So if you haven't done it yet, if you haven't actually drew the graph properly by finding the values, please do it. Don't carry on, do it. It's really, really important. The sine graph, okay, looked like that. It started at 0, went back to 1, went back to 0, and ended up at 0. So it swung start from 0, went to 1 at 90, went back to 0, went down to minus 1, and back to 0 at 360. Okay? The cosine also started at 1, it started at 1, not at 0. Okay? It went down to 0 at 90, then swung to minus 1, 180, went up to 0, 270, and back to 1 at 360. So it also swung between minus 1 and 1, but it started at different points. Okay? You will eventually learn to actually remember the shape of this by heart. What I want to do now is show you, okay, that we already noticed that 360 degrees is the same back to 0. Okay? So when I get to 360, I'm just where I started. It's the same value. Same here. 360 and 0 have the same value. But what I can open your mind now, I'm hoping, is that you can actually go beyond 360. What do I mean? Well, I can go to 450. What is 450? It means I started at 0. I did a full circle. I did a full circle around that first circle, and I got to 360. And I'm going another 90 degrees, another quarter of a circle. So 450 really is the same as 90. Okay? It's just 90 plus a whole 360. So 450 will have the same value as 90. And then I can do another 90 and get to 540. And then another 90 and get to 630. Not 60, I skipped something. No, and then another line, another 90 degrees, and then I get to 720. So I can carry on this graph, guys. I can carry on this graph. And do another whole full circle from 360 to 720. And what I get is what you call a periodic graph. You take this basic unit and you copy and paste. And paste. You can carry on. You can carry it to 1,000 degrees, 2,000 degrees. Later on, we'll see we can even go to negative angles, but we're not going to do it now. The same thing with the cosine. Okay? When I got to 360, I just was back at where I started with 0. I can do another 90 degrees, and that's going to get me to 450. And then another 90 degrees to 540, another 90 degrees to 630, and another 90 degrees, and I've finished the second round, and it's 720. Okay? So have fun with these graphs. They're really cool. Let's be honest. They really are cool. See you in the next lesson.